Modeling with logs. Example 4. What is the magnitude of an earthquake with a seismic energy of 1.8 times 10 in exponent 23 joules? So the formula for finding out the magnitude is x is equal to 10 in exponent 1.5 m plus 12. M is the magnitude and x is the seismic energy. Now, x in this case here is a seismic energy, so it's 1.8 instead of the x. We are plugging in 1.8 time 10 in exponent 23 time 10 in exponent 23, which is equal with a 10. So now we write in this form here, this formula 10 in 1.5 m, 0.5 m plus 12. And this formula we can arrange a little bit better. So let me rewrite this in the form how it is: 1.8 in exponent times 10 in exponent 23, and the other part here, the other part I want to separate those two exponents, 1.5 m. I will write in the expanded form 1.5 m, and is a time 10 in exponent 12 time 10 in exponent 12. What I'm going to do in this equation, I'm going this equation to divide everything by a 10 in exponent 12. And if I'm dividing everything with 10 in exponent 12, then this 1023 divided by 1012 is going to be, first of all, let me write 1.8 here in the beginning. And when I divide 1023 by 1012, is going to be time 10 in exponent 11. In exponent 11. And because of this side is 1012, if I divide everything by 10 in exponent 12, is going to remain just 10 in exponent 1.5 m. So now is a little bit more simple than it was before, 1.5 m. And now this I'm going to convert into the logs. If I'm converting into the logs, I'm going to have a log here, and in this side 10 here is the base of the exponent, is going to be base of the logarithm. So base is here, and 1.8 I'm going to write in the way how it is, because if I am writing expanded form, is going to be very long, so I am writing in scientific form. Is a 10 in 11, and now the other part is an exponent, which is 1.5 m. So now we convert it from the exponential form into the log form. And now we can take a calculator and calculate a little bit here. So what we are going to do here, first of all, we take this number 1.8 in time 10 in exponent 11. So if we write this number, we can write 1.8 time 10. I'm looking, it has 11 0, so I'm writing 11 0. 1 2 3 4 5 6 7 8 9 10 11, and it's going to be 18 with 11 zeros here. And now I'm getting the log, because the log is with the base 10. I'm getting the log. And what do I get here? Let me put here a little bit better position. Is 11.25 and has a lots of decimals, but let me write it just 11.25. I am approximating this number with 11.25. And in the other side is 1.5 magnitude, 1.5 m. So m represents the magnitude. So now it's very easy to find the magnitude. But everything here now I'm dividing by 1.5 of the equation, 1.5, if I divide by 1.5, so now it's easy. I divide this by 1.5, and what I'm going to get here, the magnitude is 7.5. So the magnitude M is equal with 7.5 Richter scale, 7.5. And if we are looking here in this chart, for example, is a minor, if it's a 1 to 3 to 4 is a minor earthquake, 4 to 5 is a light earthquake, 5 to 6 is a moderate, if we are looking here. And if we are going further, 6 is a strong, and from 7 to 7.9 is a major that causing a lot of damage. So this kind of a magnitude of the earthquakes makes a lot of damages. So